everyone. My name is Han. I come from Institute of Computing Technology, Chinese Academy of Science. Today, I'm here to introduce our work titled EPA-Route, Routing Payment Channel Network with High Success Rate and Low Payment Fees. Our work focuses on how to efficiently route transactions in the payment channel network. We first introduce payment channel network and its routing. We know that blockchain systems, especially Bitcoin, suffer from its scalability. Payment channel network was proposed to solve this problem. In a nutshell, a payment channel is a two-party smart contract between a pair of blockchain participants. A pair of participants only commits opening and closing of the channel to the blockchain. Other transactions are performed locally between the two parties. Either direction of a channel is associated with a capacity, which indicates the number of funds that can be transferred along the direction. We show an example. Alice and Bob both put some deposit into the channel. After that, both parties can send transactions with an amount not exceeding the channel capacity without interacting with the blockchain. Finally, Alice and Bob take back their funds in the channel after closing the channel. Payment channels essentially form a network. The essence of a transaction execution in PCN is the flow of funds, which leads to the change in channel capacities. If a transaction can be successfully paid, the routing algorithm must be able to find paths with sufficient capacity. Success rate is the core requirement of routing algorithm. Besides, in multi-hop transactions, intermediate nodes will charge some fees according to their on-site fees rate. They may set an unreasonable rate to get more fees. Therefore, for a routing algorithm, how to efficiently route these transactions so as to ensure a high success rate and low fees become a crucial issue. In the three-node network on the left, this may not be a problem. And what if the scale of the network is to the right one? In particular, channel capacities continuously varying as transactions are conducted, and the frequency can be very high. Without a centralized controller, each participant has limited visibility to capacity changes of the entire network. In this case, it is even a hard problem to find out available paths in which every channel has sufficient capacity to carry a transaction, not to mention to minimize the payment fees or achieve high performance. There are some prior works that focus on the problem, such as silent whispers, speed murmurs, flash, spider, but none of them can solve it well, especially about the payment fees. In this paper, we propose EPA-Route, a novel routing protocol for PCNs. EPA-Route addresses four design goals: high success rate, low transaction fees, high performance, and decentralization. Next, we will introduce the main procedures of EPA-Route. The first procedure is path probing. Path probing is responsible for searching for available paths and collecting attributes for these paths. When a transaction is invoked, the sender generates probe messages and sends them based on its routing table. Here is an example of how to create the routing table entries. We have the topology, and the D node is the destination, and the A is sender. We first run memory ordering and get the order DBCA. Every intermediate puts all of its neighbors whose order is lower than itself into the routing table. We can see that the routing table creates a routing graph. It's an DAG, and propagate to the receiver along the routing graph. During path probing, every node performs a pruning operation. Currently, EPA-Route prunes passes based on the capacity and the TTL, time to lab. Only passes whose link capacity exceeds the threshold and whose length is less than the max TTL are preserved. This improves the performance without compromising the success rate. And then is the payment amount allocation. The destination receives multiple probes, each of which contains information of one pass. It allocates the transaction to its received passes. The allocation is formulated as an optimizing problem with the objective of minimizing transaction fees. Sum of all amounts allocated to passes must equal to payment amount. Total amounts of all sub-transactions through one channel cannot exceed the capacity of this channel. Finally, the receiver sends a response back to the pair for each selected pass. When a response is passed along the path, intermediates will temporarily lock the corresponding allocated amount to guarantee concurrency. Sender collects all responses and conducts the all sub-transactions automatically, which means that all sub-transactions are either completed or not executed. Let's see the final evaluation result. The extensive experiments show that EPA-Route reduces up to 85% transaction fees and maintains a comparable success rate as state-of-the-art algorithms. The other experiments are shown in our paper. Please refer to our paper to see more information. Thanks for listening.